we are given a quadratic equation. I know it's a quadratic equation because the highest power of x is squared. It's an equation because we have an equal sign. Who would have thought? And we're told it has two solutions. Great. And those solutions are denoted by P and Q. So they're just some numbers, some values, right? It could be 2 and 25. It could be negative 50 and 3 million. All right, we don't know yet. But we do know that P is a greater number than Q. Okay. And the question is, right, what is the value of P minus Q? So, P and Q are solutions to this quadratic, which we can find. Once we have those solutions, we know that P is the bigger number, and we're subtracting a smaller number, so our answer should be positive. Right, that just tells us the order. So we know we're going to have a positive number. But before we get there, we need to work out what P and Q are. So to do that, we're given the equation like so. We can rewrite it in standard form. That just helps us factorize it. So standard form means we have everything on the left, and then it equals 0. Or everything on the right, and it equals 0 on the left. So I'm going to subtract 6 on both sides. And what that does is it gives us all of the x terms and the constants on one side is equal to 0. So now we can factorize. Now, looking at this, in front of the x squared term, we have a 2. So when we use our two sets of brackets here, maybe last year we'd always just put 1x in each, right? Because x times x gives x squared. However, in this example, one of them has to be 2x, because when we expand it out, we want that 2x squared. Right? Which one you make 2x doesn't really matter. But what does matter now is the next step, choosing those two numbers. So two numbers that multiply to negative 6. But this time it's not add to negative 11 because we have this 2x. So a good approach to start with is list the factors of negative 6. So it could be 1 and negative 6, or it could be negative 1 and positive 6. It could be 2 and negative 3. It could be negative 2 and positive 3. Right, those are our possible numbers that can go in here. Right, the factors of negative 6. And now you pick one. So this could be done on the side of the page, right? Your rough working, or if you're a genius, not like me, you could do it all in your head. So let's try the second one and see what happens. So negative 1 and positive 6. If we were to expand this out, we would get 2x squared plus 12x minus 6. Oh, I forgot. Minus x minus 6. Which looks similar to what we started with, but instead of a negative 11x, we have a positive 11x after we combine those two terms. So that's not right. Another thing you can do is change the order, right? So we could replace negative 1 with positive 6 and positive 6 with negative 1 and expand that out. And we'll see that it doesn't equal the quadratic that we started with, so that's no good. But we were close before, so let's try the opposite sign. So positive 1, negative 6. So that gives 2x squared when we expand, minus 12x plus x minus 6, which when we group the like terms in the middle, gives us what we started with. So just to summarize that, we got the quadratic equation into standard form, right? So everything's on one side equals 0. We noticed there was a 2 in front of the x squared term, so one of these two x terms in our factorized brackets has to have a 2, in front of it as a coefficient, so that when we expand, we get back 2x squared. Then we listed off the factors of -6, and we tried putting them in for our two numbers, just expanding to try it out, until we got the correct pair and the correct order of those numbers. But so now we've factorized it, we can solve it. So if this whole expression equals 0, either 2x plus 1 must be 0, right? Because anything times anything else, for that to equal 0, one of the terms needs to be 0. Or x minus 6 could equal 0. Right, so either set of brackets equals 0. Now we solve for x, so on 2x plus 1 equals 0, subtract 1 from both sides, divide both sides by 2. If x minus 6 equals 0, add 6 to both sides, in other words, x equals 6. Now which one of those is p? Remember, p is the greater one. The greater value here is x equals 6, so that's p, leaving us with q being -1/2. And the final step is to work out p minus q, which would be 6 minus -1/2. Don't forget the minus there. In other words, 6 plus 1/2, or 6.5. So to summarize this question, one more time, we had a quadratic equation which we put into standard form. This is a really good place to get when you're solving any quadratic problem. Because then from standard form, we were able to factorize it, solve for x, and then answer the question, what is the value of p minus q?